So we have a different tessellation pattern here, and we're just going to walk through the design process, and we're going to walk through how to turn this into a 3D printed object, similar to the series of steps we've taken before. You might notice a few of the directions are a little bit different here. I've learned a few little tips and tricks having to do with the program, so naturally I get a bit better at doing this sort of stuff. However, let's get started. So you'll notice here that we've got a tessellation, and it's a repeating pattern that will be a combination of equilateral triangles and squares. We could continue this pattern in this direction here, and we could continue the pattern in this direction as well, but we also need to make sure that it fits onto our plastic base, and we have a design constraint that the whole thing has to be smaller than 14 centimeters. So when I look at this, I should mention to the people watching the video here that this is a slightly distorted picture that is a bit, I had to stretch it to make sure that it fit on the screen properly. So although it looks like some of these squares aren't quite perfectly squares, it actually turns out that they are. Just in reality, it's just their visualization here on the screen is a bit distorted, and these are indeed equilateral triangles. So the first thing we'll take a look at here is just sort of our, okay, we'll center that, we'll go into the pen tool here, and so we'll say that this is our square right here. All right, and we'll just say that it's got a side length of 1, and I have an equilateral triangle right here. And just for simplicity, we'll say that it has a side length of 1 as well. Because as you'll notice, if the squares all have side lengths of 1, you'll notice the squares are up against the triangles, like that. And so they're going to have the same side lengths. All right. The thing we'll notice here is that this is a 90-degree angle, and that all angles inside the square are the same, as the side lengths are all the same as well. And the angle on the inside of our triangle is 60 degrees. Try to fit that in there. And all the side lengths are the same as well. And what this means is that both of these shapes are what we call regular polygons. Regular polygons are especially useful to us because they're easy to draw mathematical objects, and they tend to fit together quite nicely. At least the smaller sided ones do. After you get past, say 4 sides, it gets a bit more difficult to create tessellations with them, but it's not impossible. So what we're going to do is just sort of take a look at how big the pattern that I have on the screen is going to be. So first thing we're going to do is we'll erase some of these lines here because we know this stuff already. All right, and I'm just going to back up a touch, and now we're going to take a look at the actual sort of length and width here. So the widest part of the puzzle that we've got is from here all the way over to here. All right, so we've got sort of this distance here all the way over to here, and we have to figure out how wide to make this. And we also have our height, and that's going to be the tallest part of the puzzle is right here. So we have to figure out how long this entire shape is. All right, so that seems pretty easy because from here to here is just 1, and from here to here is a distance of 1, and we're just using 1 unit at the moment. This may turn into 2 centimeters later on, and we're just going to assume that it's 1 centimeter long for the moment, and this is 1. Now it gets a bit complicated because this distance here is slightly less than 1, and we have to actually calculate this. So I'm going to use a bit of math, and if you're the sort of person who prefers to just sort of, go out and maybe not listen to all the math stuff, pay attention for a little bit, but the math isn't, super essential for this. We'll go and calculate these distances, but we're going to use a little bit of what's called trigonometry here, and to start out, we have to draw our equilateral triangle, and we are trying to find this distance right here, which I'm calling the height. I know that this angle is 60 degrees, and I know that this distance from here all the way to the corner is exactly half of my side length, which would make this equal to 0.5 centimeters. And I also know that this, being a side length, here is also 1. So probably the quickest way to do this is to say that the sine of 60 is equal to the height, or the opposite side of the triangle, this triangle right here, divided by the hypotenuse. All right, minor detail here is that whenever you drop a height, that'll be at 90 degrees. So we've got that sine of 60 equals opposite over hypotenuse, and we can just write this out as sine 60 equals h over 1. And we can cross multiply and solve here if we're using a calculator, and we'll find out that h is equal to approximately 0.866. All right, so that would mean that our distance from here to here is actually twice h. So if we go from here, that's the height of the triangle, and that's the height of the triangle, and we have 2 more heights right here, like so. So the entire distance involves 4 h's. So what we're going to do is we're going to kind of round this a little bit just to make the calculation easier. And we'll just say here that h is approximately equal to 0.87. And so then we need to know what 4h is, like so. 8 times 4 is 32, so that's 3.2. And 7 times 4 is 28, so this is going to be 3.48, which is approximately equal to 3.5 centimeters. All right, so altogether, I'm going to have 1 plus 2h, 2 plus 2h, 2 plus 4h, 3 plus 4h, and so that must mean that my total width is going to be equal to approximately 6.5 centimeters. All right, so that means that this distance from here all the way over to here is 6.5 centimeters. And if we look, this is 1, this is 1, and this is 1. And that's h, 2h, 3h, and 4h, like so. So it looks like our total puzzle is going to have a height of approximately 6.5, and it's going to have a width of approximately 6.5. All right. Now, we also happen to know that 6.5 is a little bit, for 6.5 centimeters anyways, is a little bit small for a puzzle. And we'd like to try and make that a little bit larger. We know that the print bed, the maximum size of an object that we can print out on both 3D printers is about 14 centimeters, which means that if we take this and we multiply everything by 2, then we should end up with 6.5 times 2 is going to give us 13 centimeters. All right, so what we're going to do is, instead of saying that this side length is 1, we're going to make this side length 2. All right, and then that's going to give us a puzzle that is not 6.5 by 6.5, but 13 by 13. All right, and so that's going to be our basic design, and the rest of the puzzle is actually not going to be that complicated. It's going to be very similar to everything else that we've been doing. So let's see, I'm just going to go to insert a page, and we're going to go insert after our current. And so we're going to say that the standard puzzle base will be square shaped, like so. And just like we did before, that can be 14 centimeters, like that. And it looks to me like we're going to be able to just fit our puzzle inside like this, and we'll make this distance here altogether 13 centimeters, like so. And if we do that, we should be able to fit everything in, and we'll notice here that this margin of error here will be about 0.5 centimeters, like so. And just like we did before, it's not going to be perfect here, but the base from the side, we say we are going to make that about the same. We're going to make that 1.5 centimeters. And we're going to have a depression shape in the center that's going to be, just like we did, that'll be 7 or 0.7 centimeters deep. And the pieces, when we make them, let's just draw a piece in like this, albeit it's not drawn to scale. We'll make that 1.3 centimeters, and that means that they'll stick out like this by, let's see, actually we're going to make, yeah, we're going to make this 0.8 actually, like so. And then if this is 1.3 centimeters, then this will stick out by about 0.8, like that. Or sorry, 0.5. Oh, silly me. Anyways, so it looks to me like this will be an okay design. I may change my mind a little bit here because I'm looking at this now and I'm thinking that perhaps having a 0.5 centimeter margin here might not be uh, big enough, because usually we like to put some little text or something down here marking your name and maybe press a logo into the base here. So I'm going to think about this, but theoretically you should be able to make your puzzle with side lengths of 2 centimeters and everything should fit in nicely. I might make that a touch smaller and say instead of 2 centimeters I might knock that down to about 1.8, and then that'll make this margin here a little bit smaller. Okay, so if you notice in the video that I'm no longer using 2 centimeters, I might just knock that down by a touch, and then this outside margin here will be a bit bigger. Anyway, so that's the basic design here, and so the next video we'll get going on the drawing technique that we'll need. We'll make the base and the pieces and extrude them and shrink them, and we'll get printing. So I'll see you in the next video.